All right, so I'd like to spend a little time on talking about a little about the architecture of what it is that we're going to be building throughout the semester, right? So that we can then refer to the architecture and see where we are in the technology stack, right? So what we're going to be building are single page applications, right? Where you're going to have a browser. Right? So here's our browser, right? That is going to request one page, right, from the server. So here's the server, right? For the server, we're going to be using Node.js, and Node.js uses a particular module that is very, very popular for creating very simple servers. That module is the Express module, Express. And together, the N and the E are the E and the N in the mean stack. Okay? Node.js is nothing but a JavaScript interpreter, right, that allows you to execute JavaScript on your desktop, okay, or run it from the command line. Typically, when you think of JavaScript, you think about executing code on the browser, right? And that's its legacy, right? But today, we kind of find JavaScript everywhere. Right? It's taking over the world, and certainly Node.js is it's an interpreter that allows you to execute it at the command line. So we're going to be at the command line. We're going to be typing Node, right, and giving it a JavaScript file, right, such as Node server.js. Right, we're going to say Node server.js that executes the server code here, written using the Express module, and it's going to start listening at a particular port, okay, for incoming HTTP requests. So here it is. Our browser is going to hit that server at a particular port, so HTTP, and it's going to ask for index. All right, so index is going to live on the server. So here's index. The server is going to find index at its local file system, and it's going to serve it to the browser. The browser is going to copy it locally on the other machine. Well, in this case, all this is going to be running on our local machine, right? Eventually, you're going to deploy the server on a remote server. Right? It's going to run on AWS or Heroku or wherever, right? On your local environment, everything's going to be running on your local machine, yes? So anyway, so index gets downloaded. Here's index.html. Index.html is going to be referring to other files. So here at the top of the file, of index file, is going to be referring to other documents that are on the server, right? Some of them will be JavaScript files, some JavaScript files. And so for each JavaScript file that this index page requests, the browser is going to go back to the server and download all these JavaScripts. Download and going to be copied locally on the browser machine. Yes? Okay. Plus, it's going to ask for some way up here. It's going to ask for some CSS files. It's going to go out and fetch these CSS files. Right? It's going to download the CSS files, which are going to paint your page and make it look pretty. Okay. Some of these files, some of these JavaScript files, some of these CSS files are not going to be on our local server. Some of them are going to be referred to in somewhere in the cloud, right? Some of them are going to be on Google servers. Some of them are going to be on Bootstrap servers. Some of them are going to be on jQuery servers. Right? So several servers are going to be out there, right? And we're going to be asking for some CSS files, some JavaScript files, some images. They're all going to be downloaded by our browser, right? Locally, it's going to be cached locally on our machine. Everybody okay? So together, all these JavaScripts, all these HTML, all these CSS is what makes our application. Okay? Now, typically this index page, this first index page, is going to be mostly empty. Mostly empty. Right? If you go and look at some of the more popular single-page applications, and you ask the browser to give you the source code, right, of the page, you see that it's mostly empty. There's nothing in it, right? Or there's very little in it, right? So, wait a minute, it's got headers and footers and sidebars and images. Where is everything? Okay, it's because that first page is mostly a starting point. Okay? Everything else that you see on the screen was dynamically downloaded, right, and then rendered at a later time, like programmatically. So this first JavaScript that gets downloaded. It will be the entry point of our application. This JavaScript is going to start asking for more content. Okay? The simplest of things is that it will do the following. It says, oh, I need to render maybe a list of my friends. Okay? So this JavaScript will generate an HTTP call. This HTTP call, though, even though from the browser's point of view and from the server's point of view, it's just like any other HTTP call. Right? All HTTP calls are equal, but some of them are asking for static content. But all this is just plain old ASCII files. They don't change over time. The server is not dynamically generating any of this. Right? This is static. Comes here. But some HTTP calls, again, from the browser's point of view, from the server's point of view, it's just like any other HTTP. Some HTTP calls are not going to be mapped to some physical ASCII file. Some of them are going to be bound to some executable function here on the server. Okay? Some of them are going to be bound to a function. If that incoming HTTP request comes in, I'm not going to fetch any static files. I'm going to execute a function. And that function, I could do anything I want in there, right? I could query a database. Right? I could query a database and ask it, who are my friends? Right? And that database, looking at, this database is the database of all friends, including not mine. And it said, well, it's me. If I'm logged in, I would like to see my friends. So it'll give me a subset of the users that are my friends. Typically, it'll come back in the format of JSON, right? A JavaScript object notation, right? JSON, meaning this is a format that is already friendly with the client, right? The client wants to receive data already friendly with JavaScript, right? Because JavaScript asks for the data. It'd be great to receive the data also on the same format. The database responds with JSON, and this service, right? We call this a web service, meaning this is an executable piece of code, right? That can retrieve data on behalf of some client, right? That's a web service. That's that it's exposing some data at an URL endpoint, right? This returns the dynamic JSON that might include several objects, okay? That can get downloaded here by the JavaScript, which is expecting this JavaScript JSON to come back, and then using DOM manipulation, right? It will take the browser and ask it to add new content dynamically. Add a new div, and then dynamically add a UL, right? An unordered list, and add a line item, right? Line item where I will render my user.name, right? Or username for each one of my friends. I would like to display each one of the user's name, right? And then for the next user, add another line item for my other user's username. Right? It will dynamically render this on the client, right? Based on the dynamic data that it retrieved from the server. Make sense? Right? Notice how everywhere we see that we're using more or less the same data representation, right? We have JavaScript on the client, right? JavaScript on the server. We have JavaScript on the database, right? JavaScript is slowly taking over the world. For the database, we are using Mongo. That's the M. Okay? In our technology stack. For rendering this dynamically, right? The library that allows us to dynamically add this content, right? We're using the library Angular. An alternative implementation in other technology stacks, might have might have JavaScript here, right? Here you might have Java. That's a very common technology stack, right? And on the database you might have MySQL. That's a very common technology stack out there, right? Where you might have J2EE on this side, using some JPA or to talk to MySQL database. Using that technology stack, notice that each tier, right, each different tier of our application represents the data a little bit differently. Right? If we're going to render it here on the client, obviously we need JSON. Right? If we're going to represent instances of objects here, I'm going to need instances of Java objects. Right? And over here, right, we're going to have to represent those same instances in some row, right, some record in a table. Right? Notice that at each layer, right, that needs to interface between these two, there's going to have to be a mapping, right? Because these don't necessarily map one-to-one to Java schemas, right? Obviously, Java schemas are so much richer, right? You have inheritance, you have objects, you have all sorts of really, really interesting, much richer ways of generating classes than you have on MySQL, right, or in SQL. Yes? Right, so there's definitely going to be a conversion when you extract data from a database and convert it into Java instances, right, and vice versa, Java instances back into SQL. Right? And this one, again, also, right, you're going to have Java objects, right, they're going to have all full inheritance and whatnot, converted into a representation that is almost pseudo-object, right? You don't have inheritance here in JavaScript. You don't have that kind of same rich implementation that you might have on data modeling that you might have on Java. But nevertheless, you have this conversion back and forth between the client and the server, right? All that conversion is costly, right? And it introduces additional complexities, right? On how is that you're going to map all this data back and forth, right? And what the mean stack and many other competing MVC stacks, like React and Sail and Meteor and many other, and Ember and all these other model view controller libraries, right? Is that they provide a stack where everything all throughout is JavaScript. You have very minor or minimal conversion that you need to do between the different tiers. Right? It allows you to work the same data model across your entire tier, okay, which simplifies the overall design and architecture. Make sense? Everybody okay? All right.